Have you ever just looked at a mountain range or a canyon and wondered, why? Why isn't our planet just one big, smooth, boring ball? It's because right now, and for billions of years, a massive battle has been raging all over the Earth's surface. So today we're going to dive right into the forces that are constantly building our world up and the ones that are trying to tear it right back down.
I mean, really think about it. It's a pretty simple question, right? But the answer is just incredibly cool and complex. You'd think a giant spinning sphere in space would be, relatively uniform. So where do all the bumps and grooves come from? Why do we have this incredible variety in our landscapes? Well, it all comes down to a constant, epic tug-of-war. Our planet is literally the stage for a massive battle between two totally opposite sets of forces. You've got one side working tirelessly to build things up, and the other side trying just as hard to wear it all down.
And that brings us to the main event, what we're calling the Great Geomorphic Battle. We're going to look at the two teams in this planetary conflict, the forces that build versus the forces that destroy.
Okay, let's meet the players. In one corner, we have Team Buildup. These are the endogenic forces. They're powered by the immense heat from inside the Earth itself. Think volcanoes, earthquakes, the slow crunch that builds up massive mountain ranges. And in the other corner, you've got Team Wear Down, the exogenic forces. They get all their juice from an external source, the sun. The sun drives our weather, wind, rain, ice, and these are the tools that grind everything back down. It's a non-stop cycle.
You know, all the work that Team Wear Down does, it actually has a name, denudation. It literally means to strip bare or to uncover. It's kind of the perfect word for it, right? It's the big umbrella term for all the processes that wear away at the Earth's surface.
So how does this attack actually begin? How does Team Wear Down start its work? Well, the first shot fired in this battle is always weathering. This is the slow, patient, and relentless process of breaking solid rock apart right where it stands.
Now, this next part is absolutely crucial. Weathering is an in situ or on-site process. That means the rock breaks down, but the pieces don't go anywhere. Imagine an old stone statue in a park that's slowly cracking and crumbling over the centuries. That's weathering. The pieces are all still there at the base of the statue, they've just been broken off, and remembering that distinction is key.
And weathering has a few different tactics in its playbook. First, there's chemical weathering. This is where something like rainwater, which is slightly acidic, slowly dissolves the minerals in a rock. Then you have physical weathering, where brute force does the job. Think of water seeping into a crack, freezing, expanding, and splitting the rock apart from the inside. And finally, there's biological weathering, which is just amazing. It's when something like a tiny seed falls into a crack, grows into a tree, and its roots literally pry a giant boulder in two.
Okay, so weathering has done its job. The rock is broken into smaller pieces, but all that rubble is just sitting there. How does it get from the top of a mountain down into a valley? Well, that's our next phase, getting all that debris on the move. You can think of it as a three-step takedown. Step 1, weathering, breaks the rock on site. We've covered that. Step 2 is mass movement. This is when gravity and gravity alone pulls that loose stuff down a slope. A landslide is a perfect example. And finally, step 3 is erosion. This is when a mobile agent, like a river wind or a glacier, comes along, picks up the debris, and carries it away.
The key thing to remember about mass movements is right there in the name. It's about the mass moving under the direct influence of gravity. Gravity is the only engine here. Sure, water might be mixed in, making a mud flow, but the water isn't carrying the mud. The whole mixture is just sliding downhill because of its own weight.
And that's what makes erosion so different. With erosion, you have an active agent doing the work. A river doesn't just sit there. It actively picks up sand and pebbles and carries them downstream. It's like a conveyor belt. Wind picks up dust. Glaciers scrape up boulders. They all acquire and transport rock debris, sometimes for hundreds of miles. This is the process that carves out things like the Grand Canyon.
So, we've talked a lot about destruction, right? Breaking down, wearing away, carrying off. It all sounds pretty negative. But here's the twist. All of this destructive chaos has an incredibly important and creative purpose. In fact, it's the secret to life on land as we know it.
And here it is. This is the big payoff. That whole mess of weathered rock debris, that's the fundamental, essential #1 ingredient for making soil. Without weathering breaking down solid bedrock into little bits and pieces, we just wouldn't have the raw material, what scientists call the parent material, for soil to even begin to develop.
But it's not just broken rock.
Making good soil is kind of like baking a cake. You need the right recipe. You start with your parent material, the weathered rock. Then you need the right climate, the right amount of rain and heat. You mix in the topography. Are you on a steep slope or a flat plain? You add in some biological activity from plants, worms, and microbes. And finally, you have to let it bake for a very, very long time.
So at the end of the day, why does this planetary battle really matter? Well, for one, it creates the very soil we need to grow our food. That soil supports vast forests, which are the foundation of biodiversity. On the economic side, these same processes can concentrate valuable ores like iron and aluminum, making them easier to mine. And fundamentally, without weathering creating all that loose material, the powerful forces of erosion just wouldn't have any ammunition to work with.
So this battle is non-stop. It's happening right now as you're listening to this. Team buildup is pushing new mountains toward the sky, and team wear down is patiently grinding them away. It's a process that has shaped our past and is actively shaping our future, which leaves us with a pretty wild question to think about. With these forces always at work, what will our planet even look like a million years from now?